coming to this talk. First of all, let me start saying that I'm very excited to be here participating at the Smalltalks 2025. At the same time, this is my first visit to Argentina. So I'm very grateful to the FAST Foundation for your invitation to participate, and to everyone in this wonderful Argentinian Smalltalk community. Thank you, guys. Thank you, pibes. Sos unos capos. Thank you, Elliot, for your invitation yesterday. Thank you, Elliot, because you are another member of the Argentinian Smalltalk community, for sure. I'm Rafael Luque. I come from Madrid in Spain. I co-founded a very small software development company called Osoco more than 20 years ago. As you can imagine, it's a kind of a bit unusual software factory, a kind of weird software factory, because we like to use Smalltalk in several of our projects. In fact, every time that we find the occasion to do it, we use especially Faro and also G-Toolkit. Let me start with the presentation itself. We are going to introduce behavioral programming, obviously using Smalltalk through a basic library we have developed on G-Toolkit. I don't know if some of you have read or known something about behavioral programming or scenario-based modeling, scenario-based programming before this talk. Nobody? Okay, it's awesome, because maybe this talk is going to be useful if you understand my English, first of all. This talk is going to be also mainly about a different way of thinking about software that I believe is closer to the way we naturally understand and describe the behavior of a system under development, rather than how we traditionally code these behaviors. The subtitle, The Quest of Executable Knowledge, reflects my vision. I think that is shared by the majority of small talkers because of our epistemological vision of programming that exists in the small talk tradition. That is that programming really is about medium to better understanding the system we want to develop, at the same time that we are turning out our understanding of the system into a kind of executable models. So let's begin with the obvious first question, that is, what is this thing, behavioral programming? So behavioral programming is a kind of novel paradigm. It's not new because, in fact, it was introduced more than 25 years ago. And it's a paradigm that tries to focus on building software systems by composing behaviors in an incremental way. Behaviors understood as very small and independent fragments of behavior. So from the point of view of behavioral programming, a system is defined through these behaviors rather than algorithms or any kind of data structure like of functions or objects or whatever. So it's a kind of, it's a way that, as said before, try to bring programming closer to the way that we as humans, we developers, we are still humans, understand the way a system must behave. And it is based on a long scientific work, a long research line that spans over more than 25 years, mainly impulsed by the professor David Harel and his collaborators. The research line started with a seminal paper titled Life Sequence Charts, published in 1999 by Bernard Dunn and David Harel. In this paper, the authors describe LSCs, live sequence charts, that is a kind of visual notation similar in its form to UML sequence charts, but it expands the UML sequence charts with more formalins, for instance, multimodality. With a UML sequence chart, you only represent what a system possibly can do, but in LSCs, you can express also not only what can be possibly done by the system, but also what should be done in a mandatory way, and what shouldn't be done never or under certain conditions. After this paper on 2003, this book titled Can Let's Play was published, authored by, again, David Harel and Rami Marelli. In this book, they introduce scenario-based programming. Also, the LSC's live sequence charts, like a kind of visual language, and two techniques named playing and play out. Specifically, playing is a technique very interesting because it allows to specify the behavior of a system without to written any text. You don't have to use any kind of symbolic format like text or even visual diagrams, because it is recording the user gestures, the user actions on a UI that is representing the system under development. Obviously, the UI is a fake UI, is a hollow UI without any logic, because the system is still being developed. This is a very interesting idea, but it's a bit out of the context of this talk, because we are going to focus on behavioral programming. That is a kind of evolution of this scenario-based programming. That is the daily work of David Harel. Then behavioral programming was introduced in a 2010 article titled Behavioral Programming, published on the Communication of ACM. And by that time, it started to appear several implementations of this paradigm for different programming languages. For instance, we have available BP for Erlang, BP for C++, BPJ that runs on the Java Virtual Machine, and BP for JavaScript. And later, on 2017, appears BPJS. BPJS is an open source tool suite that runs on the Java Virtual Machine, and it allows us to express B threads in the JavaScript language. This is the tool we are using in our solution in Smalltalk as a BP core that allows us to execute B threads, but also formally verify its execution. Then a few words about why we need yet another paradigm. I think that I forgot to mention that BP is a paradigm, but I don't know if it's exactly a programming paradigm, because I feel that it is somewhere between a programming paradigm that allows us to express how a machine or a computer is going to implement something, or how it's going to be done something, and a kind of modeling paradigm or a specification paradigm that it allows us to describe the what's of the system. So what the system should do, or what the system shouldn't do. That said, we have made an incredible evolution in the software engineering field, and specifically in the programming languages field. For instance, from the initial machine language to assembly programming, and then to higher level programming languages. And at each step, we have gained more abstraction, more expressive power, and even we have invented a wide variety of programming paradigms like functional, of course, object-oriented, constraint-based, logical programming, etc. However, even if you are a very lucky person that can play and work on the most beautiful software development environment that have ever been created, that obviously is Smalltalk. Even in that case, you can feel that programming something is very joyful, but sometimes it's a really hard work. It's a really tedious, is costly, it is error prone. Programming shouldn't be so hard, I feel. Maybe we are doing something wrong, but we are doing at a higher level of abstraction. So my thesis of this talk is that there is something like an elephant in the room of software. I mean that there is something fundamentally wrong with the way we are building software or the way we are approaching the software development process itself. Maybe some of you share this feeling with me, even when we don't know exactly what is the problem or how to articulate it. But programming really is too hard. Most, not because computers themselves, I believe that is due to the way we approach the conversation between humans and machines. So our tools and our approaches to programming are forcing us into very unnatural ways of thinking about the software systems. Because if you think about it, we all as humans program every day, maybe not machines or computers, but in some sense we program people. I talk it figuratively, of course. We program people like our children, for example, or people in organizations, our workmates, our companies, governments, etc. But the way we naturally does this thing is by giving simple rules. For instance, if it rains, take an umbrella. Trying to coordinate some behaviors. For instance, wait until everyone is seated before serving dinner. And of course, we need the modality capability to express something that should never happen. And it is very important in software. But if you think about it, I think that there is very few programming paradigms or programming languages that allow you to express this multimodality. And sometimes you need to express some kind of constraints to the freedom degrees of the program. These constraints can be of the way, for example, while the plane is flying, the door should be locked. The door cannot be open anyway or under certain conditions. So we express behaviors in a natural way through scenarios, not algorithms or data structures. I love this metaphor used by David Harel. I think that is introduced in a paper about ransomware. And Harel establishes that the efforts to bridge the gap between how people think about a system and the formats that computers can execute it can be viewed as digging a tunnel from a mountain while working simultaneously from two ends. And I will add that in some way we hope to meet in the middle. I don't know how, but we hope it. On the left side of this mountain, we have the how of the system. That is the form and a system we are developing should have in order to be an artifact that can be executed by a machine, a computer. On the right side, we have the human cognition processes. That is the way we think about the what's of the system. We are trying to raise the abstraction level on the left side of this picture to push it closer to how we human reason. And for instance, as I said before, we have a lot of higher level languages. We have invented very nice paradigms like object-oriented programming or aspect-oriented programming and more. Some techniques like test-driven development. Even we have moldable development in some modern IDEs like Glamorous Toolkit. On the right side, we're trying to do something similar, pushing the way we as humans reason about assistance and its behaviors to be more closer to the artifacts that can be executed by a machine. And we have invented research ways to capture our understanding, like some of these CRC cars, object-oriented analysis and design, domain-driven design. That is a kind of, I don't know if you know this work by Eric Evans. It's a kind to focus more on the understanding of the domain of the problem that in the technologies used to implement it, so you can avoid the accidental complexity, or some techniques to capture understanding, discovery, the domain, like event storming or domain storytelling. But yet, I think that there is still a gap in the middle of the mountain, that this is a gap that represents the costly and error-prone continuous translation that we as developers are doing constantly, moving forward and backward, from right to left and from left to right through these tunnels in this mountain, because we are translating continuously our human understanding of what the system should do into some kind of system structure that is needed for the system to be executed by the machine. And after that, we have to translate in the other way the software into a human meaning again, in order to understand the system enough to be able to, for instance, fix bugs or evolve the system, adding more features. There are a lot of researchers or authors that have thought about what are the constraints that we should overcome in programming. For instance, there is this famous Turing Award lecture by John Bacchus on 1977, titled "Can Programming Be Liberated from the von Neumann Style?" And modern response by David Harel in 2008 with this pun intended title, "Can Programming Be Liberated? Period." Because it is the author, David Harel, is thinking how to liberate programming, not from the von Neumann style, but in a more general sense. And in this paper, David Harel identifies basically three main constraints of programming that he named the three straitjackets of programming. The first one is the need to express programs as some kind of symbolic format that normally is textual form, but it can also be used visual diagrams. This issue Harel tried to address in his earlier work on scenario-based programming, and the technique I mentioned before, play-in. With this technique, with this play-in technique, we can express behaviors without reading any text or diagram. but it is a bit out of the scope of this talk, as I said, because we are going to focus on BP, behavioral programming. The second straitjacket is the need to map continuously the what, that is the requirements, to the how the program is implemented. This is attention that we have already talked about with the mountain metaphor. And the third one is the need that we have to, in some way, structure also the behaviors following the same system structure that we are using in our programming paradigm. For instance, we can be using as modules of the program functions or objects or procedures or whatever. This tension is something we can view as this kind of duality between inter-object and intra-object. The left side of the picture represents the inter-object scenario-based description of a system. That could be the more natural way to think about how a system works. Is very useful, for instance, to express requirements or to think about testing. Is the natural way to think about a system. And the right side of the picture represents what we normally or traditionally do when we implement this behavior, that is a kind of intra-object and state-based view of the system. On the left side, you can see these color lines representing the scenarios. These scenarios are cross-cutting the rectangles. The rectangles represent the units of the system, functions, object, whatever. So it's a kind of description that is one story for all the relevant objects that are participating in this story, in this scenario or user story, use case, whatever. On the right side, what we have is objects or functions or modules that owns a full implementation of all the scenarios they participate. This is a duality that behavioral programming aims to resolve and narrow the gap, making the left side we have seen the inter-object scenario-based description of a system a kind of executable form directly. The description of behaviors in behavioral programming is really an executable artifact. So as a wrap up of the BP motivations, we can say that the essence of BP is to bring programming closer to how we actually think, one behavior at a time. And this goal is get through a way to the behaviors themselves are executable. So finally, the result is that the global behavior of a system in some way emerged from the collaboration of a lot of small and independent fragments of behavior that we are going to use, B threads or behavioral threads. All right, I don't know if you have slept yet. Enough theory and philosophy for now. So now I'm going to try to see how is behavioral programming in action inside Smalltalk using the library we have developed for G-Toolkit, GT4BP. Let me sit down. Can you hear me? We are going to use the ubiquitous hello world. That's probably not the best example, the best use case to apply BP because, well, it's a toy example. And BP is more oriented to be used in a kind of systems that we can known as reactive systems. That is a system where you have a lot of events, maybe a system highly distributed. For instance, I'm thinking about microservices, but any kind of services that are working in a kind of event-driven architecture. But anyway, I believe it could be useful enough to give you a brief feeling of how is to use behavioral programming. Before, as a reminder, if I am sparking you a little bit of curiosity about this paradigm and you want to dig deeper in the paradigm, you are, of course, invited to the hands-on workshop we are going to be celebrating tomorrow at 4 p.m. I don't know if it will be in this room or another room, because we are going to play with a bit more complex example. You can also explore these examples and all the documentation about the GT4BP library, exploring the notebook that is accompanying the library when you install in your image. Let me show you. When you install this library on your image, you are going to view this kind of section with material related with the library. This one, well, this one is this presentation, and this another one. It's a notebook, a Lepiter notebook, with a set of pages describing the design of the maybe a large. It's a set of pages accompanying the library, describing the design of the library, but also the implementation. It is not a kind of dead documentation, but really this is the source code of the library we are using in this project and other projects in Osoko, a kind of approach that we have known moldable literary programming, because it is the old literary programming by Donald Knuth. Maybe some of you know this approach, where you mix documentation and source code fragments, but we are mixing these ideas with the more modern tools, the moldable tools we can find in GToolkit like this Lepiter. So really, if you go to the GitHub of this project, you don't find any source code. You find this set of explanation as the source code of the project, and we can generate the code from the explanations. Simply, we install at the first step a little extension we have built for Lepiter, known as Lepiter Literate, and with this extension installed, you are going to see this kind of icon on each page of the notebook that allows you to tangle the code inside this page. And you can also tangle, of course, in one step, all the code from the notebook. So the way to get the Faro source code, or in this case, the GToolkit code for the library, is to tangle the notebook. The notebook is the source of truth of the project. And we are using this approach in all of our projects in Smalltalk. So let's see the Hello World sample a la BP. We are going to define, don't worry about if you don't understand the syntax right now, because we are going to explain it after. But I think that the sample is so simple that we can some way understand what it's doing without too much explanations. We are going to define two B threads. The B thread name hello, BT hello, BT from B thread, and the B thread name war, BT war. We are registering this B thread in some way through this function on the BP object. The hello B thread is going to declare a synchronization point through this BP sync function. At this synchronization point, this B thread is requesting a simple event named hello. And the second B thread is doing something similar. At this synchronization point, the B thread is requesting a world event. So now if we follow this example, we instantiate our BP runner. Sorry. I don't see what is the icon. Yeah, I have instantiated our GT4BP runner. Now simply assign these strings to these variables. You, you may notice that the bitrate is not Faro code or Smalltalk code. It's simply a string because we are, as I have said, we are using right now as BP engine BPJS, and BPJS, although it runs on the Java virtual machine, it is designed to express the bithreads themselves as JavaScript. So sorry about that. It's something we are working on to have a more native Smalltalk experience. But right now, you have to write the bithreads in JavaScript. It's not very problematic because bithreads by definition are very simple and very short. Now we have this defined and simply add these two bithreads to our runner through this message .bprogram. And we are subscribing to any BP event that the B program can emit or can publish. We are going to simply print on the transcript this event as a string. So if we are now open the transcript, well, I'm going to clear it, and we can run. We can run the B program with these two B threads. And sorry, but I don't see if here say hello or world, but anyway, maybe it's hello, then world, or world hello, because um, okay. Sometimes when you run this B program, the result is going to be hello world, and other times the result is going to be world hello, and this is the expected result. This is the intended result because we have defined simply two B threads that are independent between them, and they are not coordinating in any way. So what we have here is simply pure concurrency without coordination. This is useful because it allows me to show how, in a behavioral programming way, approach the forcing of the order and we fix this hello world version that is non-deterministic. The way we do that with BP is simply adding more B threads. BP encourages you to make changes, adding more B threads or removing B threads, but not you don't have the need to rewrite your code or the existing code. Even something you don't have the need to understand or read about the behavior of the existing system. And you can modify it, adding threads, simply knowing the set of events that these B threads are coordinating on. So we are going to start from our previous hello world non-deterministic, that is this one, and simply we add a third B thread, this B thread enforce order. This B thread is at its synchronization point is declaring that waits for the hello event, and at the same time it is blocking the world event. So this is the way, as said before, we can use multimodality with BP. And we are, with this third B thread, is between the world event until the hello event is emitted by the system, by the B program. So when we add this third B thread to our previous hello world version, we obtain the hello world version that with a deterministic behavior. And we can run this version, and always we are going to obtain hello world in the correct order. So although this is a very tiny sample, I think that it's useful. We can give these main takeaways about BP, because we have seen that BP allow us to think about behavior in a modular and incremental way, because we have passed from the first version of Hello World to the deterministic version, only adding more behaviors. We have compositionality or additivity, because it allows us to, as we have seen, change our system behavior simply adding or removing bit instead of rewriting the existing code. And finally, the global behavior of the system in some way emerges. Is not centralized, emerges from the collaboration between each piece of each fragment of behavior. Um, as you may be thinking, I think there are a lot of connections between these ideas and object orientation, of course. A few words about the main concepts of behavioral programming. We are been talking about B-thread. B-thread is a sort of for behavioral thread. We can understand this behavioral thread as a kind of fragment of behaviors that are small and independent between them, and that allow us to describe, as we have seen, what should and what shouldn't happen under certain conditions. They all run concurrently with other B threads, and they are in some kind participating in some way participating in a kind of synchronization loop that is coordinated through a catalog of common events shared between these B threads. And another definition, a behavioral program or B program is simply software that is using BP, so consists of a set of independent B threads. The collaboration between these B threads is what it generates a flow of events of the program. And how it works behind the scenes. The protocol is very simple. It's a kind of publication subscription protocol. When a B thread reaches his synchronization point, it waits until all B threads reach their own synchronization points, and then each B thread declares something, some kind of claim about the events. For instance, it can declare the requested events, that are events that the B thread is expecting to be triggered by the system. And it also asks to the system to be notified when this event is selected. It can declare about the waiting for events, are events that are not requested by the B thread, but the B thread wants to be notified when the B thread is selected. And also the blocking event is the mechanism to vetoing events from this B thread. Once all these declarations are collected, our BP engine filters the events that are requested by B threads and not blocked by any other B thread. And from this set of events, maybe one event or more than one event, this set of events, the system choose one following some kind of event selection strategy. And this event is notified to those B threads that was requesting this event or was waiting for this event. These B threads continue its execution until reach another synchronization point, and then this loop starts again. So a few words about our library GT4BP. GT4BP is a very early basic library that brings BP into GToolkit. Although it is a very basic library right now, it allows some interesting things. For instance, we can execute B programs. Well, first define B programs adding B threads, and then the B program is defined. We can execute this B program directly from GToolkit. Although this library has been developed in GToolkit, really it doesn't rely heavily in any GT-specific feature. So we have plans to evolve this library into a more neutral BP library that you can use in any kind of Smalltalk dialect. Probably will rename the project as BP4ST. And about the architecture, as I said, we are using BPGS. BPGS is a kind of embedded library in Java. I mean that it is a jar library. We have developed this box that is a BPGS bridge in order to be able to smoothly integrate a Smalltalk side with this Java process. This BPGA bridge is a lightweight mediator, and it's simply Marshall and unmarshal events using JSON format through the standard input and standard output. It's very simple. And here on the left side, we have the Smalltalk virtual machine with our image. And GT4VP has two main abstractions: a runner that is what we have used in the Hello World sample, and the verifier that allow us to make formal verification of the B program. So we can develop a kind of hybrid Smalltalk application, for instance, where the business logic of the application or the decision-making logic is built on a B program that consists on this set of B threads. And for instance, the graphical user interface can be built in a traditional way inside the Smalltalk using Block or other graphical toolkits. Or if we have, for instance, a service or microservice, then we can follow, we are, for instance, following a kind of hexagonal architecture where the domain model of the service is implemented as a B program, and the ports and adapters around this domain model that wrap the domain model in the hexagonal architecture are implemented traditionally in Smalltalk. Okay. As I said, GT4VP already is providing us some features interesting, like we can add B threads to a B program currently written in JavaScript. We can run and stop the B programs. We can send external events from the Smalltalk image to the B program. External events because these are events that are not requested by any B thread, are events that come, for instance, from the user interface, making clicks or making some kind of action in the graphical user interface. Or in the case we have a microservice, these events could be events providing that are consumed by our microservice from a Kafka topic or RabbitMQ topic, for instance. We can also obviously receive behavioral program events emitted by our B program. And as a powerful feature and extra bonus that provide us the use of behavioral programming is that it's much easier formally verify our B programs than if we follow a traditional programming paradigm, because the space of states of a B program is very small. And in the case the verifier find a violation of the verification, we are receiving in the Smalltalk side the counterexample with all the traces of the BP events corresponding to this counterexample the verifier has found. We are right now supporting only the verification of safety properties. That is the things that the program should never done. But we have plans to add also verification of liveness properties because PPGs already support that. So we can add it easily to the BPGS bridge. Finally, this GT4VP library is a small part of a broader project called Advice, from Advanced Vision and Intelligent Software Engineering. This is a project we are developing, collaborating with the Rey Juan Carlos University in Madrid. And mainly the project goal is to explore how generative artificial intelligence can participate in a meaningful way in the software development. By meaningful way, I mean that we don't want to replace engineers by AIs, but we want to augment its capabilities, its intelligence in a way like the Douglas Engelbart augmented intelligence, human intelligence vision. This is a project with two complementary approaches. Osoko is working, Osoko is my company, is working on ideas from scenario-based modeling, that is things like LSCs, play in, play out, and of course, behavioral programming. And the university is exploring this STCL, that means specified test check loop, that is something similar to the TDD's cycle that is used as a good practice in a lot of projects, for instance, some free or open source software projects. As I said before, both frameworks are meant to augment human expertise and not eliminate it. For that, we are trying to follow this, again, David Harel's vision about what is computing. And what is computing is about the computer should be like other member of the development team, an active and collaborative member of your development team that is, for instance, asking questions, offer suggestions, like you was doing a kind of pair programming with this computer. The role of Osoko within Advice is to lead the research and development of this thing we call SM Toolkit, that is a scenario modeling toolkit. Our vision is to build a kind of Smalltalk-based environment focused on the modeling, the understanding of behaviors of the systems, and not so much on source code and the how side of the programming. This toolkit is going to contain several tools, like, for example, live sequence chart editor, LSC snippet to embed these LSCs on Repeater notebooks, also an LLM agent that helps you to create the LSCs from the natural language description of its behavior. Obviously, a mechanism to be able to execute these LSCs, and this is the point where we need the GT4BP library, because our idea is to translate LSCs into a behavioral programming semantically equivalent to the LSC, and then run the behavioral programs. Finally, our goal with this SM toolkit is to be able to build the kind of services, or sometimes microservices, that we are currently building using Smalltalk code in my company. But we want that the source codes be replaced by this kind of notebooks describing the design of the system, the behaviors, the scenarios, and these scenarios can be formalized using LSCs. These LSCs compile into B programs, and B programs can be executed by a computer. So in some way, we are going to, our vision is to, in the future, have this kind of executable knowledge or executable domain models. To sum up, why behavioral programming matters? I don't want to sell behavioral programming as a magical solution for all the problems of programming. It's not my intention. But I think that exploring behavioral programming and other ideas from the David Harel's research is very worthy. And as I said before, there are some points connecting this research with the philosophy behind Smalltalk, I believe. Behavioral programming itself is very useful because, as we have seen, allow us to focus on behavior rather than on the system structure. We can add logic incrementally without understanding the previous existing system. And also, as I said, it's a very powerful feature to be able to verify that your program is formally correct, I think. So BP is a step towards turning our understanding of a system in some kind of executable knowledge. Um, I think that is all I got for today. So thank you for your attention. If you have any question or thoughts.
Thank you for the presentation. In one of the slides in the first part of your presentation, the cognitive gap, you a bit before that, yes, there. You describe with a couple of examples what is understanding and the kind of understanding we want to translate or to bring to the computer. Okay, and there are three great examples there. If it rains, take the umbrella. Wait until everyone is seated before serving dinner. While the plane is flying, the door cannot be opened. So there are several things in those three statements. References to objects, actions that this object can take, in some cases, actions that the reader can take, events, conditions, time, um, permission, and forbidding things. I It's not obvious to me how all these elements of these examples of knowledge can be translated into B threads and B programs. Can you elaborate on that?
Yeah, of course. Basically, in BP, you can express this kind of behaviors using a set of events. The mechanism to coordinate between B threads is the event. In our Hello World example, we use a very simple event. It's simply a name, hello and world. But for instance, if it rains, could be an event, and we can it's an external event. It's an event you can receive through a sensor, for instance.
It's a condition, not an event. If it rains, it's a con- if it rains, it's a condition, not an event.
Well, you can express like an event. For instance, rain started. You can express even in past tense like an event and rain started.
So you need a way to convert conditions like if it rains into
Yeah,
events, and you need to convert objects like umbrella into events or everyone into events. I mean, it's not obvious to me.
yeah. Maybe this is a bit weird. The weirdness I think that comes because it's something new. We are very accustomed to think in object-oriented terms. I love object orientation, but for instance, when we are at my company working on highly distributed architectures in an architecture based on events, we are continually converting this kind of conditions and objects into events. For instance, between microservices, they are coordinating, interchanging events through a kind of messaging bus, like RabbitMQ or Kafka or whatever. Uh, we can think in a microservice that emits and publish an event in a RabbitMQ exchange that is rain started. And we have another microservice that consumes that event and reacts to it. And it can react taking the umbrella. So it's a different way of think about the programming, more than programming, a way to express behaviors that allow us to run it in a machine after that. I think that if you come to the hands-on workshop, maybe it's going to be more illustrative because we are going to play with a bit more complex than the Hello World, that is a very silly example to show how BP works.
I think my question has to do with my lack of experience with behavioral programming, but it has to do with the relationship between the first half of the talk and the second half of the talk. So, in the first half of the talk, you said that the goal of behavioral programming was to align programming with human understanding, right? And then in the second half, you showed us some examples where you have like the B threads and you have the program that could print hello world or world hello. So I guess my question is, how does that align programming with human understanding? Or if you have any concrete example where we are able to see that alignment
Well,
using behavioral programming?
very good question. Indeed, I have some doubt about that because, as I said before, the earlier work of David Harel is not behavioral programming; it's scenario-based modeling or scenario-based programming using the formalizing of LSCs and play-in, play-out technique. Um, I feel that the scenario-based modeling, I like it much more scenario-based programming than behavioral programming. And I really don't understand why Harel says that BP is an evolution of scenario-based programming because I understand in the reverse way. And this is the reason why, if you notice that the SM toolkit, this is a project we are working with the university. We are trying to build an environment to express behaviors not as B programs, because BP is much more closer to a traditional program. But it's a kind of program where you have invented a kind of universal mechanism to run it, that is this loop of synchronization. And you propose that all B threads interchain events between them. And this is the way to get very loosely coupled, very loose coupling between B threads. But I like much more scenario-based programming and LSCs. And so we are working on expressing behavior in a natural way using your language, translating this language into LSCs with the help of AIs or directly in a manual way using the LSC editor inside the G toolkit. And these LSCs are going to be translated into B programs, but these B programs, from the point of view of our approach, is like assembly programming for us. We don't expect to see or understand these B programs. What we want to use as the source of truth of our system is simply a book, plenty of pages describing what the system should do or shouldn't do. The formalizing is a visual notation that is very easy to understand, even for stakeholders, not technical stakeholders. That is the LSC.
I have a question related with the use of BPJS, that the thing that you're, is kind of a stack.
The architecture.
Yeah, the architecture. It's like, my question is, because of course the example you gave was really simple about the hello world, posting a message, getting an event out of that. Would that be, could you implement the same thing using, I don't know, I'm thinking the things I know, like an async framework where you get events and streams of events and stuff like that? Would that be a way to implement it? Because maybe I'm not getting the whole concept, but
this is almost a proof of concept. It's a proof of concept. We are decided as first decision to build a prototype to use an available tool that is BPGS, and build this BPGS bridge that is using a very simple mechanism, marshalling and marshalling injection through a standard input and standard output. This could be evolved into something more elaborated, but we are avoiding this because our plan for the near future is to implement the BPE engine inside the Smalltalk. So we are not used. Sorry, we are not use these kind of mediators between Smalltalk and a BP engine that is external to the image. We want to implement the BP engine natively in Smalltalk. This is going to give us the opportunities to more smoothly integration, the support of specific tools, for instance, for monitoring the state of the B program or the B threads, or even a specific debugger for the B threads.
If you got to build kind of a real project or system using BP,
I don't know.
Sorry,
I don't know yet.
and how do you go about debugging a BP program?
Okay. As I have just said, our plans include build the PP core inside the Smalltalk, and after that we can build a specific debugger for the B threads. So you can have you can do step-by-step execution, or even a kind of breakpoints inside the B threads, but because the B threads will be simply Smalltalk code. Okay, thank you.